Section 6.1, Graphing System of Equations. Essential question. Do all systems of equations have one solution? Well, first of all, a system of equations is more than one equation. We are going to be focusing on two equations every time in this chapter. So I'm going to write down two equations as my vocab definition. So each equation is going to have two variables in it, making it a system of equations. The solution to a system of equations, there's a couple possibilities for what your solutions can look like. You can have one solution, you can have no solutions, or you can have infinitely many. So one, none, infinitely many. All right. So you are given a graph. And what we need to do is look at two specific lines on this graph. And we're going to answer two questions. What kind of lines are formed and how many solutions does this system have? So we need to look at y equals negative 3x minus 5 and y equals 2x minus 5. So I'm just going to jot down the colors on the right-hand side here for which lines we're looking at. So the negative 3x minus 5 is our green line. I'm going to take the green pen and write green. So that's this one right here. And then we're also looking at 2x minus 5, which is our blue line. So if you look at the green and blue line, what the green and blue line are doing is crossing. When two lines cross, we call that intersecting. So where it says what kind of lines are formed, we're going to say intersecting lines. So lines that cross are intersecting. How many solutions does this system have? So think to yourself, if two lines cross, how many times are these two lines touching each other or crossing each other? They're crossing each other once. The blue and the green line cross each other right here. They cross each other one time, so there is one solution. And we are also going to name where they intersect. So that ordered pair right here would be 0, negative 5. So that's where those two lines intersect. So I'm going to add in there 0, negative 5. So green and blue are intersecting lines. They have one solution at 0, negative 5. All right. Same type of thing, except this time we're going to look at two different lines. So now we need to look at y equals negative 3x minus 5 again. So that was our green line. And we're going to look at negative 4x plus 2y equals 4. Now you'll notice that none of those equations, or that equation isn't listed on our graph at all. So what we're going to need to do is make it look like one that is on there by getting it into slope-intercept form. So off to the side, I'm going to write negative 4x plus 2y equals 4. And I'm going to get this into slope-intercept form, meaning we want to get y alone. So add 4x to both sides. I'm going to scoot this over because I'm not going to have enough space here. So add 4x to both sides. Those will make 0. Bring down the 2y. And then we have 4x plus 4. Remember, keep those separate because they're not like terms. And then to get y alone, I'm going to divide every number by 2. So we've got y equals 2x plus 2. Now if I go back to my graph, 2x plus 2 is the red line. So that's right here. So there's my red. And then remember, we also have to look at this green line. So let's look at what the red and green lines are doing. So what kind of lines are formed? Well, the red line and the green line are crossing. So just like the last problem, they are intersecting. How many solutions does this system have? Well, remember we said on the last one, if they intersect, it is one solution. And then if there is one solution, name it. I don't think I had scrolled up so you could see that on the last page. But if there is one solution, name it. So yes, there is one solution. Now what you'll notice about this one doesn't intersect at a nice ordered pair like the last one did. So we're just going to guess. So we're going to the left about 1.5. So we're going to say negative 1.5. And then we're going down about 1/2. So we'll say negative 0.5. So it intersects, not in a nice ordered pair, but I think we ended up with something close enough. So the green line and the red line are intersecting one solution at the ordered pair negative 1.5, negative 0.5. Okay. Next one. All right, our first one is negative 6x plus 3y equals 6. Now you won't see that equation fall on our graph, so that means I'm going to need to get it into slope-intercept form. So just like we did on the last one. So add 6x to both sides.
If there's a Davis McGuire in the building, please come to the front. Your dad is here for you. Davis McGuire to the front.
And then to get y alone, we have to divide every number by 3. So then we have y equals 2x plus 2. So 2x plus 2 is our red line. So we're working with the red line. And then we have 2x minus 5, which is right here, which is our blue line. So if we look at our red line and our blue line, our red and blue run next to each other, but are never touching each other. Those two lines are parallel. And one other thing we know about parallel lines is that parallel lines have the same slope. So if you look at the red line has a slope of 2, and the blue line has a slope of 2. So yes, those lines are parallel. Parallel lines have the same slope. How many solutions does this system have? So how many solutions do parallel lines have? Well, parallel lines never ever touch each other. So they never ever intersect. So there are no solutions because they never ever touch each other. So you're really thinking about intersecting lines touch each other once. So that's why there was one solution. Parallel lines will never touch each other. So that's why there are no solutions. All right. Third one, we have 4x minus 2y equals 10, which that one does fall on our graph. It is the blue line. And then we have y equals 2x minus 5, which is also the blue line. So you'll notice that there are two different equations going to the same line. And that's because we have equations just in two different forms. If I get this into slope-intercept form, we'll have y equals 2x minus 5. So this matches that. So even though we had one equation in slope-intercept form and one in standard form pointing to the same line, they're the exact same equation, just two different forms. So that's why they both go to the same line. So if two equations fall on the same line, the equations are the same, the lines are called identical. Both equations make the same line. How many solutions do identical lines have? So two lines that are directly on top of one another would intersect an infinite number of times. So they have infinitely many, infinitely many solutions. Now we don't need to name all the solutions because we've been naming them forever. Every single ordered pair is a solution because the lines are the same. So you only have to name an ordered pair if there is one solution, so if they're intersecting. Okay, so now you have a big grid that you are going to need to fill into your notes. So how many solutions does a system of equations have? So the number of solutions, we had 3 different possibilities. We could have ended up with one solution, none, or infinitely many. Try that again. F-I-N-I-T-E-L-Y. Okay, so I'm going to jump down to my graphs. So lines that have one solution intersect one time. So there is what my graph looks like. And like I just said, they intersect. 9 lines that have no solutions are parallel. And lines that have infinitely many solutions are identical. All right, so let's talk about the equations for these lines. Let's go over to the identical one first. If 2 equations make the same line, they have to have the same slope and the same y-intercept because they're the exact same line. If 2 lines are parallel, we know that parallel slopes stay the same. So they also have to have the same slope. But they have to have different y-intercepts, meaning they cross the y-axis at different different spots. So we're just going to say what's in common is the same slope. And lines that intersect can't have the same slope because it's not parallel and it's not identical. So we'll just say different slopes. The y-intercepts could be the same or different. And really we could add in here that you have to have a different slopes for this one. You can't have the same slope and the same y-intercept, or sorry, not different slope, different y-intercept. So let's go through that again. Lines that intersect have to have different slopes. They could either have the same or different y-intercepts. Lines that are parallel have to have the same slope, and they have to have different y-intercepts. And lines that are identical have to have the same slope and the same y-intercept. Summary.